Okay, so today we're talking about functions and doing really complicated things to functions and how to graph them when you're done. All right, to begin with, this one's different than what we normally do because why? Because the stuff that's changed is on the left-hand side. How do I fix that? How do I get the 0.5 there to get to the right-hand side? Yeah, because it's divided by 0.5, so I multiply by 0.5. If I do that on both sides, notice that the 0.5 is on the outside. So I'm going to change this to y equals negative 1/2 is the same as 0.5, right? X. Now, there's two things happening there. There's a flip and there's a stretch or shrink. Now, it's on the outside, which is up-down stuff. Okay, outside is up-down. What's inside? Left, right. So this is outside stuff. So it's up-down stuff. So that's an up-down flip. That's pretty easy. And what's that, though? The 1/2. Half as big. You can trust the stuff on the outside to do what you'd expect. All right, but the stuff on the inside, you can't trust to do what you'd expect. When it does this to you, I'll keep it simple, that's not twice as wide. It is a wide thing, but it's not twice as wide. It would be half as wide. All right. What if it's like this? Does that still mean half as wide? Yes, it does. It's just half as wide and what? Move it to the right 3. Is that exactly the same as this? No. Only the one on top actually moves to the right 3. The one on the bottom wouldn't. The one on the bottom, you'd have to, if you wanted to see how far to right to the movie, you'd have to factor out the 2. It'd be very complicated. And then, how do I factor a 2 out of the 3? Well, I got to figure out that times that makes 2x. That times that would have to equal 3. 2 times what would equal 3? 3 over 2. Now I could see that it's half as wide and it's a move of 1.5 to the right. Well, anyway, the point here is that those parentheses make a difference. We wanted you to have the parentheses in there because that's the only way that you'd actually be moving it 3 to the right. A lot of people's tests look like this, and then they got them marked wrong because they didn't have the parentheses in there. Okay? All right, so what is a question like this asking me to do? It's asking me to take the V shape. Notice it's an absolute value, so that's the V. And it wants me to do a bunch of stuff. 1, 2, 3, 4 things. But I want to know if you know the right order to do them in. Now, there is a stretch there and there's a flip there, and I think that's going to be the hardest part for you. And I'm going to give you something to remember that by. Okay, if you were in gymnastics, do you think you would flip first or stretch first? Stretch first, and that's why you should stretch and then flip. All right, I'll give you another example from my youth. I was a basketball player, and our head basketball coach one time, just after practice was done, grabbed a ball. I was going to play a little pickup with one of his key players, and so he hadn't warmed up or anything. And so he goes to make a quick move, like a jag step kind of a thing, and his Achilles snapped, and it went like pop, like that kind of a noise, and you could hear it all the way across the gym. I wasn't in the gym at the time. I really wish I was, because it was apparently something to behold. You hear this like pop, and then he goes down because your Achilles is this one that, like, you know, the big one sticks out in the back of your leg there. It's really thick. I mean, when that thing broke, you could hear it again across the gym. And another thing about the Achilles, when it breaks, it ravels. It's under so much tension that it's kind of like a rubber band. It pulls up into your calf. So it's like all rumpled up inside your calf. And they have to like surgically go in there and tug it back down and sew it back together and everything. And you're in a cast for a long time. Anyway. Oh, yeah, you can't walk. That's why when the wolves are trying to bring down the deer, that's what they do. They get the Achilles tendon. They get the Achilles tendon, then the thing can't run. And then, anyway. Happy thoughts, happy thoughts. Okay, so stretch before you flip. I'd like you to write the right order then and say, okay, first it needs to be reflected over the y-axis, then it needs to be whatever, okay? That kind of stuff. Well, we'd like you to write the 4 things in the right order. I will tell you that it's the 2 of them won't matter what order you do them in. Is that true in math too? Yeah, there are some that the order doesn't matter, some types of things. All right, so number 1 thing I already said, got to stretch before you flip. And number 2 thing is the flip. But its official name is a reflection. And is it an up-down one or a left-right one? Up-down one, because it's on the outside. And up-down goes over the x, so it's a reflect over the x-axis. And the 3rd and the 4th thing are the ones that won't matter what order they're in. It doesn't matter if you move it up first, up 7, or left 5, but those are the 2 things you have to do. Okay, I'm going to say left 5 and then up 7. It won't matter if you do the up 7 first. Now, one general rule, though, that I want you to know for pre-calc when the problems get significantly harder is that it's smart to do all the stuff on the outside first and then the stuff on the inside, or all the stuff on the inside first and then all the stuff on the outside. It actually will work either way. But what we need you to know for now is, just practically speaking, when you're doing one of these problems and you've got a graph that's supposed to be moved and it looks like that to start with, that you should first stretch, flip. Stretch first. And then what? And then flip. And then after that, the moves, I don't care. You can move it however, move it left, right, and then move it up, down, doesn't matter. Okay. Next thing I need you to know is this guy right here. When you're doing that one, you might say, but you've never told us what to do when you divide. But you can change any divide problem into a multiply, right? So isn't that really multiplied by 1/4? Same thing as divide by 4, right? So isn't this the exact same thing as if I had said y equals 1/4 x like that? Right? Exactly. Why didn't you say 1/4 is big? Because it's on the inside and you do the opposite of what you'd expect. So it's not as 1/4 as wide, it's 4 times as wide. All right, so if this thing looked like a V to start with and it got 4 times as wide, it's still going to be a V, but it's way wider. It's like somebody grabbed the edges of it and pulled it and made it way wider. In fact, its slope would become, instead of a slope of 1 like the original, this would have a slope of 1/4, which makes some sense because, see, there's sort of like a 1/4 there. Anyway, main thing is that you know what's happening on each of these and then how to handle it when you have a problem like this one. If I'm going to move this thing left, right, up, down, or stretch it especially, I really need to know what its parent points are, what its main points are. So I'm going to make a list of these 5 points. I'd like you to make the list with me. -5, -3. I know we did one like this yesterday, but still want you to write them down. -2, 3. 2, -1. 3, 3. And 5, 4. So there's my originals. Now, when you get asked to do this to a function, I'm going to make it even harder. I'm going to put in a 2 in there and a parenthesis. Okay. When you get asked to do a hard one like that, here's what you do. Don't try to even start until you've written down the points. Once you get the points, then you just need to do the right thing to those points. Like, is this stuff in here X stuff or Y stuff? That's X stuff. It's left, right stuff. So those are my X numbers. So I have to take each of my X numbers and I have to do 2 things to them. I have to do this 2 and I have to do this -5 thing. But it's on the inside, so you don't double them. What do you think you do? Cut them in half. And then, remember the right order, and then I do the minus 5, except it's the opposite of what you expect. You don't do minus 5, you do plus 5. So I take all of them, cut them in half, and then add 5 to them. I'd like you to do that and make a new list. Don't mess with the y's yet. Just take these x numbers that we had, cut them in half, and add 5 to them. I'll help you with the first one. For example, negative 5, if I cut it in half, it's negative 2.5. And then I add 5 to it, and that's going to become positive 2.5. And the y hasn't changed yet. Don't mess with the y's yet. So you cut them in half, and then you add 5. So this one, Nolan, cut it in half. Close. And then add 5. There you go. Get the idea? Okay. Mr. F in the back. Next couple. Cut this in half and then add 5. 6 is correct. Cut this in half. And then add 5. Okay, 6.5. Cut this in half. 2.5. Add 5. All right. Now we're going to have to go do the y's. Mr. N, tell me what thing I have to do to the y's. I have to do 2 things, actually. Times them by 2. And then how do I do a flip? It's really as simple as you might think. Times it by a negative. Yeah. So how do you times by a negative? Well, you just reverse its sign, right? So I'm going to take everything, and should I stretch first or flip first? Just remember this, even though in this case it wouldn't matter. Usually it matters. Stretch first. So I got to stretch it and make it twice as big, and then do the opposite sign is what it was. So let's do that. Take this y number here. First stretch it. Makes it 6, and then change its sign to positive 6. Done. Do that for the others, please. You need to be writing these on your paper with a pencil or a pen. I know some of you are already done. Doubling it, negative 2. Changing its sign positive. All right, Mr. G, what are they? Negative 6 and what? You are correct. Then, if I graph this, I can compare it back to the original one, which I want you to think of as sort of like an N with a little flag. Do you get how it's sort of like an N with a little flag on it? A capital N? All right. So it should still look like that. Except, what should it be done to it? It should be, what's this thing again? Narrower. And it also should be moved, which way? Right. It should be twice as tall, and the end should be upside down now. All right, so when we're all done with it, you see how what a pain that would have been if I told you, okay, all I want you to do with this N is to flip it over, make it twice as tall, make it half as narrow, and then move it over to the right 5 and do it all at once. It'd be impossible, especially when you add that flip in there. Because I could maybe see an N, like moving an N and making it smaller and taller and stuff, but then when you got to do an upside down N, it'd be about impossible. That's why we do it this way with the points. All right, so now I'm going to take these guys and I'm going to graph them. And I want you to make a little sketch of the graph of them. And see if you can see, when you're all done graphing it, if it really looks like it's narrower, taller, moved to the right, and flipped. There's the end part, except it's upside down. Get that? You get how it's narrower and taller than it used to be? And the fact the end's flipped means it's upside down. That's right, too. And then the little flag. Okay? All right, that's how you do the tricky ones. You make a list of the points, and then you just do the stuff to the points that it says. So I'm going to give you one like that. I want you to try this one. Let's say I gave you 2, 3, 5, 7, and 8, -2. And that's so that it was just simple. Those 3 points got connected by dots. And I want you to do this to it. 3f of -2x minus 1. Those are your parent points. Make me the child. Whoa, that was weird. Whoa, what's happening? Come on now. Why won't it? There we go. Okay. Make me the child points that you'd have for this one. I'm going to just sketch a little graph while you're doing that. If I connected all my dots, it would be a triangle that looked kind of like that. That's how I start. And then the child points that you'd graph will probably still be a triangle, but it's going to be flipped. It's going to be narrower and taller, and it's going to be moved a little bit to the right. All right, here's the child points. On my x's, I'm going to start with the y's because they're way easier. On the y's, all I got to do is triple them, right? So I take the 3 times 3 is 9, 7 times 3 is 21, and -2 times 3 is -6. Raise your hand if you had your y points right. Okay, good. The x points, you just have to take the numbers and do them the right things to them in the right order. Okay, and stretch before you flip, so I'm going to double everything. Then I'm going to change its sign. Then I'm going to add 1 to it, not subtract 1, add 1 to it. Remember, it's always the opposite of what you think. Yes? Ah, I said double it, didn't I? And instead, I should not double it. I should half of. Good. So I should half them all, and then change their sign, and then add 1 to them. What's half of that? 1, and then change its sign to -1, and then add 1 to it, and it would become 0. Half of this, 2.5, change its sign, -2.5, and then add 1. -1.5. And the last one, 8, half of it, 4, change its sign, -4, and then add 1. All right. Now if I graph those 3 points, I'm going to graph them over 0 up 9, over -1.5, and up 21. Holy cow. It'll be way up here. And then over 3 and up down 6. It's way over there. Is it still a triangle? Yeah. Has it been stretched up, down? Yep. Has it gotten narrower? It's been squished narrower. Has it been moved to the right? That's a tricky thing. It doesn't look like it's been moved to the right. Looks like it's been moved to the left. Why? Because when you flipped it, and it flipped it over to the other side. Okay. And that pretty much covers all of it. Okay. So that's about as hard as they will get. The only other thing, and this, sometimes kids think these are like really complicated because they don't give you any points. Say I had to do that to that, and I had to graph it. Well, wouldn't it be nice if I gave you the parent points, and then you could just do what I just showed you a second ago? But couldn't you make your own parent points really easy? If I stick in a 1 for x, I get 1. If I stick in a 0 for x, I get. And if I stick in a 2 for x, I get. And if I stick in a -1 for x, I get +1. And if I stick in a -2, I get. There's parent points. See what I'm saying? You just made them by sticking numbers, anything you want in for x. Generally speaking, stick in small numbers. Okay, and then when you've got your parent points, now I can just take all my x's and do what to them? Add 4 to them. And that'll be 1 becomes +4 becomes 5. And 0 plus 4, actually I probably shouldn't do it on top of the parent points. Undo that. 4, and then I think you get the idea. I add 4 to all of these. I'm wrong. It's 5. +4 is 5. Add 4 to this one's 4. Add 4 to this one's 6. Add 4 to this one's is 3. Add 4 to that one is 2. And then I can go change my y stuff by timesing it by 3 and then subtracting 2. Notice I said and then. The order does matter. If you subtract 2 and then you times it by 3, you'll get them wrong. You got to do things in the right order. Okay? So that's how you do them. And your homework is that worksheet I gave you yesterday. I told you could get started on it early if you wanted to. So then now it's finished that worksheet. Check it on Schoology. Now you may have noticed it's a fry pan in the front of the room. Why? Because I'm going to talk about stretching and shrinking. When you cook things, do they generally stretch or do they shrink? Yeah. Now it does depend. I think there's more things that shrink. But can you name some things that when you cook them get bigger? Yes. Bread. If you start out with bread in a pan, it is way below the edges of the pan, and by the time you're done cooking, it's way up over the top of the pan and puffing out. Yes, bread definitely expands. What else you got? Marshmallows. Agreed. You stick ever tried marshmallows in the microwave? I've heard that Peeps in the microwave are particularly impressive. You know those little bird thingies? Never tried it. Have you tried it? I got to try it. Yes. Rice, definitely. It's a tiny grain of rice, swells up to be like 3-4 times its size. All right, but what I'm doing is I'm taking shiitake mushroom. Why shiitake? Because it's fun to say. And these shiitake mushrooms, if you cook them, what do you think they're going to do? They're going to shrink. Now, to be able to talk about this, we need to know the math behind it. So shrinking, what we want to know is what percent of change is there? Like, is it going to be 25% shrinkage? 90% shrinkage? Okay. And to figure out a percent of change, you need to know this little formula. And I think it's kind of glossed over in the middle school because not many people seem to remember it. It's change divided by the original. I'll give you an example. Let's say I had something that had been 10 centimeters long and it goes down to 8 centimeters. What is the change? 2 centimeters. Divided by which one was the original? 10. And so when I take 2 divided by 10, that would be 0.2, which would be what percent? Are you paying attention back there? Please pay attention. All right. Change is 2. Original was 10. 2/10 is 0.2. What percent is that? 20%. That's 20% shrinkage. All right. What we're going to figure out is what percent shrinkage a mushroom has as opposed to what percent shrinkage a mystery item has. Has anybody already heard? What is it? Squid is correct. I'm going to go get the squid and we'll figure out what percent of change it is. Change divided by original. All right. I got to go get my gloves because they bite. Okay, so let's see how long the shiitake mushroom is. I'd like you to write this part down. Mr. Shiitake is 7.3 centimeters. 7.3 centimeters. In case you ever wondered, the perfect temperature at which to cook squid and mushrooms, it is 340 degrees. All right, and copious amounts of butter is always good. All right, so I'm going to cut up some extra chunks of mushroom in case there's some kids that would like to try some shiitake mushroom chunks. The stems aren't as good. They're kind of like, well, they're kind of tough. I don't know about gross. Now, let's talk about squid. What's his name? Squidward, yes. No, he's already dead. They use them a lot in fishing. And here is a little squid. You see the little pointy thing on the top? And yes, they had ink in them. And one of the things that I think is interesting about these guys is that they are a hollow, basically a hollow tube. Okay, and inside that tube, you have got they don't have a skeleton like you or I have, but look at this. It's like a plastic leaf that's inside the inside the no, the plastic thingy is not, but the tube, the whole tube is very edible. And we will be taking one of his tentacles and measuring that in a second. All right, so this little plastic leaf thing, it's basically like his spine. They need something to keep them, you know, like moving forward. Yeah, they don't want to just be a blob. They want to keep their form. Okay, now it does have the eyeballs down here at the bottom. I don't know if you can see those. I'm not going to try frying those up. Even if you want them, I'm not going to let you have them. Now, I'm going to take one of these tentacles here, and I'm going to measure that. And these are going to be pretty dramatic on how much they shrink. All right. Now, I want you to take a guess. Right down next to your octopus number there. I want you to take a guess what percent shrinkage on the shiitake mushroom, and then what percent shrinkage on the octopus. All right, the octopus, sorry, squid, you're right, is 11 centimeters is how long his tentacle is. All right. Now, to make it easier and less gross, I have got the cleaned squid. Looks much more normal, like fish. This is the tube part, see that? Of a much bigger squid. Okay, and actually it was about that long, but I used the first half of it in the other class. Okay, so they get to be much bigger. Unless you're talking giant squid, which are like 3 times the size of your car in the same shape. Okay? Yeah. Bigger, in fact, bigger than that. And they're one of the few animals that can handle taking on a whale. Like they can attack a whale. So, anyway, it's true. A lot of whales along the side of them, they have these huge scars on their side. And it's from battling giant squid down deep in the ocean. So this is the part I'm going to cut up into little chunks in case you want to try some squid. No, I'm not letting you eat it raw. That's disgusting. Have you ever heard of calamari? That's in rings. There it is. This is calamari. That's the other official name for it. Calamari is just squid. It's just they wouldn't sell it in the restaurants as much if they like to order up some squid. They give it a fancy name like calamari, and it sounds cool. All right, to know how much to cook up, I got to get a feeling for how many people are interested in trying some squid. It's really pretty good. All right, good. Lots of adventurous people. You don't have to if you raised your hand, and if you didn't raise your hand and there's enough left, you can still try it. Okay. So now, our squid piece, though, that we're going to actually be shrinking is the tentacle. I want predictions on what percent shrinkage you think the mushroom will have, and what percent shrinkage you think the squid we'll have. Write them on your paper, and we'll see whoever gets closest will be our master of the day. All right. Everything's better with butter. There's always one of you in the crowd. All right. Bacon is, no doubt, bacon is very yummy, and I can't really beat bacon. But there are some people that are religiously, like, they can't be around bacon, and that's why I don't do bacon. Otherwise, I love the smell of it, and it does shrink up a lot. But I don't want to make anybody have to leave, which actually that is the case for some people. Yeah, even being around it is like, I'll give you an example. Yeah. So, and there's multiple religions actually that have problems with pigs. So anyway, I personally eat the piggies, but there are people that don't. Okay. The longer one right here, and I haven't cut him. Don't worry. Okay. So now I'm going to. This isn't going to work real well for people in the back row, but you'll see how long this thing is. And I don't know if you'll be able to see it shrinking up just as I set it on the hot griddle. The thing just like, people in the front row can see this. Pretty dramatic shrink. Well, here, I just touched it to it and see how much shorter it is. And it gets way shorter. You're right. It's a lot about getting the water out of it, and that's what most shrinkage is based on. Get off of me! It does. It is kind of eerie because it will move, and it gives the illusion that it's alive, and obviously it's not. All right. All right. So now I'll get the rest of my squid going here. I did make a squid meal. I named it for my wife for her birthday. Calamari and fuego. You know what that means? Calamari on fire. And so at the end, we just add a little bit of alcohol and then light it on fire, and it makes the sugar that's in it kind of, it makes sugar caramelize. That's right. So, yeah, we eat it at home. Not a lot. I got one kid in my family that loves squid, and two that well, it's okay, but they don't really like it. Then my adventurous daughter who likes squid, we also make, let's see, escargot. You know what that is? Snails. She loves them. She seriously loves them. I can't, she can't have too many of them. She's in 7th grade. She loves snails. Now, they're in their shell, too, so it's like a big, giant snail shell. And they don't scream. Don't worry. No, they're dead. Oh, okay. You don't crunch through the shell. At least I don't crunch through the shell. We just dig them out of the shell with a little thingy. All right. My little tentacle has shrunk up enough here that I can measure him now and see what % shrinkage we got. I'm sure it'd probably shrink even more if I left it on here forever, but it's pretty much done. Okay, please write this down next to squid. It has shrunk to 3.8 centimeters. So subtract, find the difference, the change. Take change divided by original. What percent shrinkage did we get on Mr. Squid? 48% shrinkage. Did anybody verify that? Was it 0.6 something, or was it, because this formula doesn't need to be changed. Okay, so what was the change on the squid? Not percent. I'm talking just how much did it shrink? 7.2 over what was the original on the squid? So when you divided those two, what do you get? 0.654. Okay, so that's 65% shrinkage. Who was close to that on their guess? 68 is going to be tough to beat. Anybody beat 68? 63 and 68 are pretty dang close. 63 compared to 65 is tough to beat, though, so I think 63 wins it. Congratulations. You want a Kit Kat bar, they're right up there. All right. Now on the mushroom. Time to measure mushroom. I think they're done. Oh, be quiet. Okay, I believe you. 4.7. Mushrooms down to 4.7. What was it in the first place? 7.3 down to 4.7. Difference is what? 2.6 divided by 7.3. About 36%. Who was close to that on the mushroom? 35. Oh, they're equal. Oh, okay. Thank you for being honest. All right, Mr. G, you're Mr. Kit Kat now. All right. I believe he's telling the truth. All right, so those that were interested in trying the mushroom is ready. And you would come up and grab a toothpick and use it to stabberize a piece. And to start with, this is just about mushroom. If you want mushroom, come up and get a chunk of mushroom. You will be able to get squid later. It's not done yet.